So good morning, happy Monday. We're getting to the end of March, guys, which is really exciting. Um, so we're gonna get started today with a little review of what we did last class, and then we're gonna be starting on working backwards. So notice how we're multiplying today. That's what our goal is today. We're gonna start the process of doing everything we've been doing so far backwards. Okay, and we're gonna spend quite a bit of time doing it. So it's really important that if you guys have questions or comments that you guys ask, because remember, this is all about you. So please use chat to ask questions. Use your microphone to ask questions. Please ask questions if you guys are stuck. All right, so let's get going on this. So we had a little bit of a warm-up here. And remember, warm-ups are just a little bit before class. So what we're going to do here is, remember, to multiply, we're doing the box system. And that's really important because what we're going to be working on is the backwards of the box over the next few classes. Okay, so this is a 2 by 2. So I'm going to make my box a 2 by 2. Right, so this is a 2 by 2. So it doesn't matter where you put the binomials. So again, it doesn't matter if you put the first one on top or on the side. Okay, all that matters is that they have a side. Okay, then what we're going to do, and I hope you guys remember this process. So we drew a box, and then we labeled the binomials on the sides, and then we are going to just multiply to find these small areas in the middle. Okay, so just like we would a multiplication square. So we always do the numbers first. So -3 times 2 is -6. And then x times x, that's x squared. Remember, when something multiplies by itself, right, that's x squared. And if it does it 3 times, that's x cubed. Also remember, guys, that calculators are super useful. So make sure you guys are using calculators to do that. Okay. Next, let's go here. So I have a whole number. So 5 times 2 is 10. There's no x's here, but there's one x there, so that's going to stay, right? So 5 times 2x is 10x. Here, okay, I got a negative times a negative, right? So that's going to end up being positive. So -3 times -4 is positive 12. And then I have an x. And then -4 times 5, right? Now I'm going to have to do some 5s with my fingers, right? So I got 5, 10, 15, 20. So I'm going to, and this is negative, so it's going to be -20. Okay, so that's the first step. The first step, right? This is second step. First step, we draw the box. We put our binomials on the outside. And then the second step is we're just finding the area of all these small boxes. But we want the area of the big box. So to do that, we're just going to add up all of these small areas to get the total. So let's see what we have. I have a -6x squared. I have a 10x and a 12x and a -20. Okay, so there's 4 little boxes, and I got 1, 2, 3, 4 terms. So then what I notice here, right, is that we can combine like terms. So I'm going to have -6x squared. I have 10x plus 12x. So that's going to be 22x and then -20. So my final answer here is going to look like that. Okay. How are we doing? Does anybody have questions about that before we move on to the next one? Cool. All right. And remember, guys, if you have questions, now's the time to ask, right? Because it's not a YouTube video yet. When I post it to YouTube, then it's a YouTube video. That's when you can't ask the video questions, right? So to do this next one, notice how this one is 2 terms, but this one is 3 terms. So this is a binomial times a trinomial. So when I go to draw my box, the only thing difference is I might make it a little bit longer. Now, when I do it this way, then it does matter where I put each one, right? So the binomial on mine is going to have to be like this. And then I'm going to have 2x squared plus 3x minus 4. So it's the exact same process. It's just now we have to do a little bit more multiplying. Okay, so I'm going to do x times these 3, and then I'm going to do negative 3 times these 3. So x times 2x, well, the 2 stays, right? Because 2 times 1 is 2. And then I have an x here, and then how many x's do I have here, right? X squared. So let's remember, x squared equals x times x, right? So x times x squared is going to be x times x times x, right? So there's that squared. So how many x's do I have? I have 3 x's, right? I have 3 x's. So this would be 2x cubed. Okay. And then 3 times 1 again is 3. So then I have x times x, that's x squared. And then I have negative 4 times x, which is just negative 4x. And again, if you guys have questions, or if you want me to re-explain something, just let me know. And then I'm going to do this bottom row now. So now it's negative 3 times 2. Well, negative 3 times 2 is negative 6. And then that x squared, there's no x here, so that x squared just stays the same. Okay. And then I have 3 times negative 3, that's negative 9. And then there's no x here, so that x just stays. And then I have negative 4 times negative 3, so that's going to be a positive 12. Okay, notice our neat little pattern, right? I have the x squares in the diagonal, and I have my x's in a diagonal. So I'm going to write these all out. So I'm going to add up every single little square to get the total area. So that's 2x cubed. And then I have plus 3x squared minus 6x squared. And then minus 4x minus 9x plus 12. Right? So all I did was take all of these numbers, right, all of these small boxes, and I'm adding them up because I want to find the total area of the big box. So it looks like I can group some things together. So for example, here I have 3x squared minus 6x squared. So that's going to be the same as negative 3x squared. And then here I have negative 4 and negative 9, so I'm getting more negative, right? So that would be negative 13x and then plus 12. All right, so are we doing okay, guys? Did I go at a nice, like, was the pace okay? Were you guys able to keep up? Does anybody have any questions? Remember, you can always private message me, so people don't have to know if you're saying, hey, I want to go slower or I have questions. All right, guys. Well, so multiplying, right? We've been doing multiplying since at the end of elementary school, right? So multiplying is something we've been doing for a long time. So what we're going to start with today is the opposite of multiplying. And you know what's the, you guys can use chat. Type it in chat. What's the opposite of multiply? So I should be getting responses. What's the opposite of multiply? I need to know you guys are paying attention, and there we go. Yeah, there we go, guys. Yeah, so the opposite of multiplying is division. So we worked on multiplying last time, so what we're going to work on today is division. Okay? Now, of course, right, my job is to make this easy, but of course, sometimes math has fancy words for things, and it's like, why do we have to learn more fancy words, right? So the kind of division that we're going to be doing, right? So this kind of multiplying and this kind of division is actually a special type. And it's so special that it has its own name. So what we're going to be working on, so this is 7.5 day 1, and it's day 1 because we're going to spend multiple days on it. Okay. So 7.5 day 1, we're going to practice factoring. Now, you might have heard of the word factoring before. Okay. Factoring is just a special type. So it's just a special type of division. Okay. So I don't want people to think factoring is like this like crazy new thing we're doing. We're just doing division. We're doing the opposite of multiplication. Okay? Don't think of this as as a brand new thing. You guys can do this. You guys know how to divide. So what makes this special is that we have to figure out what we're dividing by. Okay? So it's a special type of division where we need to find what to divide by. Okay, so that's what makes it special. They're not like, hey, divide everything by 3. We have to find out what we want to divide by. Okay. Okay, and that's what makes it special. And that's why sometimes it makes it frustrating for people, is because we're not just dividing, we have to figure out, okay, what do I divide by? So what I'm trying to do today is we're going to start out really nice and easy, and we're just going to try to work our way into more complex problems later. Okay. So to do this, we're going to need another vocab word. So the first vocab that we're going to have is the greatest common factor. So the greatest common factor. That's what we're going to be focusing on today. The greatest common factor. Okay, so let's kind of break down what greatest common factor is. The greatest means biggest, right? Okay, so when I say greatest, I mean biggest. There should be 2 G's there. I left space for a G in my brain. I just didn't write it. I'm so sorry. Oh my gosh. All right. So biggest. Okay. Common means that they share it. Okay. And then factor is a number we divide by. Number we divide by. Are you guys okay with me using this? I know your generation thinks this is a hashtag symbol. This means pound means number. Okay, so the greatest common factor is the biggest shared, I should say shared, number we divide by. Okay. So that's what that means. Maybe just another way of thinking of what greatest common factor means. Okay. So we're just going to work on this today, guys. We're going to do a couple of examples. Okay. So let's do a bunch of examples of this, because I feel like just writing down definitions isn't going to strike a chord with you guys. Okay. So let's take a look at 4x to the 4th plus 24x cubed. Okay. And the question that we're going to ask ourselves is, what is the biggest term? So what is the biggest term we can divide everything by? So what is the biggest term we can divide everything by and still have a whole number? Okay, so what is the biggest term we can divide everything by and still have whole numbers? Sorry, I just realized that's a lot of writing, and I said I wouldn't do a lot of writing, so I feel kind of bad about that. I just feel like some of us don't write things down unless I write them down, so I just want to make sure that sometimes I say things that are important. Okay. So there's two parts to this. We want to look for the biggest number that goes into both and the biggest letter. So step one. Biggest number that goes into both terms. I should say all terms. Okay, so biggest number that goes into all terms. What numbers, you guys can use chat, what numbers divide into 4 and give us a whole number? So what numbers divide into 4? Can you guys give me some examples? Two. Yeah. So like, I know, right? 2 times 2 is 4. Okay, so 2 times 2 is 4. What's another way we can get to 4? There's one more way. What do we got? So there's 2 times 2 and there's 1, right? So 1 times 4. Okay. And then what about 24? What things multiply to get 24? Six, and what? 6 times 4. All right. What else, guys? What else? How else do we get to 24? What times what? 8 times what? 2 times 12. Oh, there we go. They're all coming in now. 2 times 12. 3 times 8. What about 24 and 1? 24 and 1. That's... I like multiplying by 1, right? Okay. So what we just did is we looked at these whole numbers. Now we want to know the biggest number that goes into all terms. So I'm just going to go ahead and box here. What's the biggest number in this first part? The biggest number is 4. Okay. So notice how 4 is bigger than 2 and 1. And then 24 might be the biggest number here, but we want it to go into all terms. So we see a 4 right here. Okay, so do you see how 4 is the biggest term here, and then 4 also goes into this term? So the biggest number that goes into all term is 4. Okay, and that means what we're going to find out is we can divide both of these by 4 and still get a whole number. And it's the biggest number we can divide by and still get a whole number. I hope this is making sense. I know sometimes when you go too slow, you lose the meaning, okay? And then 2, what is the biggest letter that goes into all terms? Oops. Okay, so now we want the biggest letter. So to get the biggest letter, we're looking at x's. Okay, so let's take a look at this. X to the 4th, that's x times, oops, my blue pen is dying. X times x times x. And then this is x times x times x. So what's the greatest amount of x's that I can divide each term by? What do you guys think? How many x's can I pull out of both of these? What's the biggest number of x's? You guys can use chat. So yeah, this one's x to the 4th, right? So we're not doing numbers. So this one has 4 x's, right? So if I tried to pull out 4 x's out of both of these, can this one handle taking 4 x's out? Can this one take 4 out? Yeah, so what's the biggest amount of x's I can factor out? Okay, so if I say 4, so again, this one I can take 4 out of here, but there's only 3 here, right? So if I want whole numbers, I don't want negative exponents. So it turns out you totally can pull out 4x's, right? But we just want whole positive numbers. So it's going to be 3, right? So there's 3 here. I can pull 3x's out here, and I can pull 3x's out here, right? So if I pull 3x's out here, I'm going to be left with 1 left over, right? So here's 3, and then here is 3. So I can pull out a maximum of 3 x's out of each, right? This one has 3 to give, this one has 4 to give, but 3 is the max that I can, and the keyword is all terms. Yeah, no, I get it. That's we're learning, of course. Okay? All right? So notice how 4 is the biggest number that divides into both of these, and 3x's is the biggest amount that I can pull out there. So what we're going to do is we're going to pull this out. Here, I should add an x. Okay. So step 3 is we're going to pull. And I'm just going to like this, because right, this means factor. Factor, you can kind of think of as pull out. We're going to pull out oops, I should go like this. That's confusing if I write it like that. I'm going to go like this. Right? So I can do 3x's, which is the same as x cubed. Okay, so I'm going to pull out 4. Oops, let's do it colored. I was doing so good with colors. 4 and then x cubed. That is 3x's. Okay, so what is this going to look like? I'm just going to scoot over here. So this is going to look like, so I'm going to have the 4x cubed, and then we have to figure out what's left. Okay, so we have to figure out what's left. So if I pull out a 4 out of this first one, do you guys see how I'm pulling out a 4? Right? So what's left is going to be 1. So there's just going to be a 1 here. And then if I pull out a 3, then there's only 1x. So this is just going to be x. And then here, if I pull out a 4, then I'm going to have 6 left. And then I'm not going to have any x's like that. So this right here is our answer. Okay, so that's it. We pulled out, we factored out 4x cubed, and then that's what left. So we took this and we're dividing by 4x cubed. That's what factoring is. Now, some of you guys are going to really like guess and check. So you can check your answer. Okay, so if you want to check your answer, you can just multiply. Right, so you can go 4x cubed, and then you can go times x times 6. So let's check our answer. I have 4, and there's a 1 here, so that's 4. I have x cubed times x, that's x to the 4th, which is good, because right here we have 4x to the 4th, and then 4 times 6 is 24, and then x cubed times nothing is x cubed. So notice this is the same as our original. So what we're doing is we're doing our multiplication backwards. I'm going to hit pause there. The first one's always the hardest one. How are we doing there, guys? We doing okay? Why do we do x plus 6? Because if I factor out a 4x cubed, x plus 6 is what's left. Right? If I multiply these, I get back to my original. So what we're doing is we're doing the opposite of multiplying. We're dividing. So we're dividing everything, right? We're dividing everything by 4x cubed, and then what's left over is x plus 6. Because 4x to the fourth divided by 4x cubed is x, and then 24x cubed divided by 4x cubed is 6. And so that's how we get the x plus 6. You can think of it, think of it like this. Let's say you have a big family, and you're going to the grocery store, and you have a shopping cart. And you're going to buy 4 of these x to the fourths, and you're going to buy 24 of these x to the thirds. But you have a big family, so you're going to have to split it, right? So what you're doing is you're pulling that out, and then this is what you have left. I mean, that's one way of thinking of it. Okay? And the reason why mathematically we do it is it makes math so much easier, and you're going to find out in a couple of days why we do this, that this is going to be really easy to do math with. Whereas this is really difficult to do math with. This, oh my gosh, is super easy. Okay? So I know right now it's like, why are we doing this? That's why we're doing this. It's going to make our lives so much easier. Okay? Let's try another one together, but this time we're going to do it a little bit faster. Okay? So let's do this. So let's say we're going to factor. Okay, so that's what we're doing. We're going to factor, and we're going to factor 12x cubed plus 3x squared. Okay, we'll do this one just a little bit faster. So we're going to have 2 steps here, right? So number 1, we want the number. So we're going to take a look at this. What's the biggest number, whole number, that goes into 3 and 12? Right? What number divides into both those numbers? What's the biggest number? Well, and if you guys ever need help, always start with the smallest number. Right? And a lot of people, right? Like, yeah, look at the smallest number, because 3 is prime, which means only 3 and 1 go into it. So then if only 3 and 1 go into it, does 3 go into 12? Yeah, it does. So the biggest we're going to pull out here is a 3, right? And you can always, hey guys, you can always just double check, right? So I might go, hey, 3 divided by 3, that's 1. Okay, that's a whole number. And I can go 12 divided by 3. That's 4. Okay, so 3 goes into both. Okay, 3 goes into both. Then I'm going to look at my biggest letter. I don't have a symbol for that. So this one has, I'm going to use blue. This one has 2 x's, and this one has 3 x's. So what's the most amount of x's we can take from both of those? If this one has 2 x's and this one has 3 x's, what's the biggest amount we can take from both? Yeah, now, and be careful, it's not just that we're taking 2 x's, we're taking x times x, which is x squared, right? So I don't want people to get confused that we're adding, right? This is x times x times x. So it's not going to be 2 x's, we're not adding them. It's x times x, which is x squared. So I can pull out a 3 and then x squared. Okay, I see where I might have confused some people with the way I'm writing this, but see how this is multiply, not addition. So when we multiply, that means the shortcut is exponents, right? When the shortcut for multiplying is exponents. So if I was adding here, I can do a little side thing, right? If I was going x plus x plus x, that would be 3x, because the shortcut for adding is multiplying, but the shortcut for multiplying, that's exponents. Okay, so we're not doing this. We're not adding. Okay, so I'm going to pull out a 3 and an x squared. So what do we have here? We're going to have 3x squared. Okay. So now so this is a difficult part for a lot of people. We have to work backwards. So you can think of this as two ways. You can divide this by 3 and divide this by x squared, or we can just guess and check, right? Some people just love guess and check. 3 times what gives me 12, right? 3 times 4 gives me 12. And x squared times what gives me x cubed? Well, I just need one more x, right? Okay, because x squared times x, that's x times x times x, that's x cubed. Okay. Are we doing okay, guys? I know this is going to be new. We're going to have to just practice and practice. So I have 3x squared times 4x, and then 3 times what gives me 3? Well, it's 3 times 1, and we're lazy. We don't write 1. So, and then we have x squared. So it's really, I just want this term to show up there. So that's just 1. Okay? And remember, if you ever want to check your answer, right? So if you ever want to check your answer, just go, okay, I have 3x squared, and I'm going to multiply that by 4x plus 1, right? So you can always just do it. So 3 times 4 is 12. X squared times x is x cubed. And then 3x squared times 1 is just 3x squared. So this should be the same as the start, right? So those should be the same. Now, if you're like, you know what, Kraft, I'm following you, but I'm struggling with this, guys, I get it. And it's hard because I can't show you why we do this until you guys know how to do it. So it's kind of frustrating that way too, right? So it's new, it's kind of different. It does make a little sense, but it's kind of like, why are we doing this, right? So we're just going to keep practicing, because if we can get good at this, guys, we're going to have a way to solve for x. So solving for x here is almost is insanely hard without a calculator. But solving this for x is going to be so easy. And it's going to be called the zero product property. So zero is a fun number, and product just means multiplication. So we don't really have multiplication up here, but we change it to multiplication here, and it's going to make solving things super easy. All right. I'm going to have you, some of you guys are in different, you guys are all in different places, but I'm going to have you guys try this one on your own, okay? So we're going to factor, and I want you guys to try this on your own. So we're going to have 8y squared, so it doesn't matter that I changed the letter, minus 24y. Okay? So I want you guys to try to get as far as you can with this, right? I even broke it up into little steps. So if you guys want, you can use the steps to help you out. Okay. And I'm going to give us a minute 30 to kind of just play around with it and see how far we can get. All right. I know, hey guys, I wish I could give you more time, but the whole point of that short time was just to get you guys thinking, struggling, trying on your own. Right. And hey guys, I'm getting these wonderful comments in chat. It's okay to be confused here. And I know we hate being confused, but it's okay. What's important is that everyone I saw are confused in different parts. So what's important is, as I go over this now, super focus on where you got confused, and we're going to overcome that. Okay. So the first thing I'm going to look at is the number, right? So what am I going to factor out? So when I'm looking here, I'm looking at, okay, I always try to always start with your smallest number, right? What numbers go into 8? So that's 8, 4, 2, and 1. Okay. So then always start with your biggest and then work your way down. So does 8 go into 24? I think we did that earlier, right? 8 does go into 24, doesn't it? Isn't that one that we worked on earlier? So 8 times 3, right? So 8, right? Because 8 is the biggest number that goes in here, then I can just stop, right? That's why we always start with the smallest number first, because we're looking for the biggest for both. 24 has bigger numbers for 24, but for both of these, my biggest is going to be 8. Now, for people who were stuck there, does anybody have any questions? How I did that? I'm just looking for all the numbers that divide into 8 evenly, right? 8 divided by 8 is 1. And then I'm like, okay, the biggest number I got was 8. And then I'm just trying to say, okay, does that get number in? Now, if 8 didn't go into 24, I would try the next biggest number. I would try 4. And you guys can use a calculator, right? So to do this, you can just be like, okay, I have 24. So 24 divided by 8 is 3. It's a whole number, right? I also see 24 is divided by 4 as well, but I want the biggest. I want the biggest, okay? And then we're going to go to the biggest letter. Okay. Now the biggest letter I have, right, y times y here, and I have just one y here. So what's the most amount of y's I can pull out? How many, guys? How many y's can I pull out? 1, right? So it's just 1. Now, we don't normally write this, but it's just y to the 1. Right? So it's 1 multiple of y, right? So again, like, we don't normally write that 1 there because we usually are lazy, right? Mathematicians are lazy, but it's y to the 1. So I can pull out y to the 1. Okay? Because remember, it's multiplication. So y, just y. Okay, so then our last step here is we're going to factor it out. So I'm going to have 8y. Okay, and then I'm going to figure out what's left. So I always do the multiplication method because that's the one I always just do guess and check. So 8 times what gives me 8? Well, that's just 1, right? 8 times 1 is 8. And then what times y gives me y squared? Well, y squared has y times y. So if I just have y, I need a y there. Because I know y times y will give me y squared. So 8y times y would give me 8y squared. Okay. And then the next one, I have to think, okay, 8 times what? Now see how this is negative? Do you guys see how this is negative here? 8 times what gives me negative 24? Well, that's going to have to be negative 3. Right? See how I get that negative in there? Because this is a negative up here. So it's going to have to be 8 times negative 3. And then the y, there's already a y there, so we're done. That's it. And you can always check your answer. Right? We could get 8y, and then I have a box here, so y minus 3. So I get 8y squared, and I get negative 24y. How did I get 3? Because I know 8 times 3 is 24. Am I wrong there? Did I? You know, I'm prone to mistakes. So 8 times 3 is 24, right? So I got the 3 because I have to get 24 here, right? Right? I'm kind of working backwards. So I know 8 times something is 24, and it has to be negative, right? So I know 8 times, right? 8 times 3 is 24. And that's what we had said here, right? 8 times 3 is 24. So then I go 8 times negative 3. That gives me negative 24. And you can see in my work, right? 8 times negative 3 is negative 4. And then I have that y there. I hope that, does that make sense? Does that help out? And hey guys, this is going to, it's going to be frustrating because it's working backwards. Like, remember when you're babies, it takes a long time just them to walk forwards, right? But then walking backwards is harder because you trained your brain to walk forward. So this will be difficult because we're working backwards. Okay, which is why use your strength of working forwards to double check your work. You can kind of guess and check, right? So let's say I put a 2 here. Well, 8 times 2 doesn't give me 24. So you can kind of guess and check. You can put a number there and then check it and then be like, oh, that was the wrong number. And then you can come back and fix it. We're just going to keep practicing, guys. We're going to keep practicing. We're going to keep practicing until we make some progress. So here's another one. Okay, so we're going to factor. Here, let's try this one. 2x squared plus 8x. Okay, I'm going to give you guys another minute and a half to try this one. And remember, guys, try to get a little bit farther than you did last time. Okay? Be like, hey, I got stuck on this last time. I'm going to do one more step here. I'll show the work from last time. You guys can do this. I know you guys can do this. All right, guys. So hopefully, if you didn't get all the way to the answer, you got hopefully further than you did last time. So let's take a look here. I got my number. So I'm going to look at my smallest number is 2, right? That's just 2 and 1. Does 2 go into 8? Sure does. So the smallest number I'm going to be able to pull out is a 2. Okay. And then let's take a look at my biggest letter. Okay, so I have x times x here, and I have 1x here. So what's the most I can pull out? Well, I only have 1 here, right? So that's as many as I can pull out. And so what's my answer going to look like? Well, I'm going to pull out a 2x. And I'm going to have, what's going to be left? Well, 2 times 1 is 2. And then x times what gives me x squared? Well, it's got to be x times x. So there's going to be an x here. And then 2 times what gives me 8? 2 times 4 gives me 8. And then there's already an x there. Okay, and that's that. And we can check our work. And I'm always doing this check this work, guys, because we can do multiplication. So this is part of like the guess and check part, right? Is that if we can do this, right, then you can work backwards. So 2 times x, 2x times x is 2x squared, and 2 times 4 is 8, and then I have an x there, and yep, that's what I had before. Yeah! Guys, I know you can do this. You guys always act surprised. You shouldn't be surprised. All right. Hey, again, some of you guys are getting the answer. Some of you guys are getting stuck. You don't get frustrated because we're all going to be in different places, and that's okay. We're going to have time for one more today. So you guys are going to try this one on your own. And again, you're just going to get farther than you did before. So let's try this one. This one's going to be might be more difficult than the last one, but it's the same process. Okay. So I'm going to give you guys a minute 30. Try to get as far as you can. Oh, sorry. I was helping people out in chat. The time went away. So this one might have been just a little bit difficult because why I say it's more difficult is when you look at the smallest number is 6. Does 6 go into 15? Right, well, right, we would try it. So 15 divided by 6. Oh, man. So we're going to have to do a little bit more work than just does the smaller number go into the bigger number. So then we think, okay, well, what times what gives me 6? So 6 doesn't work. What about 2 times 3? So we'll see if 3 goes into 15. So if I go 15 divided by 3, I get 5. So 3 times 5 works there. So the biggest number isn't going to be 6, it's going to be 3. So again, I checked just to see if 6 would go in here first. It didn't, so I had to go with the next big number. So I was like, okay, 2 times 3 is 6. So then I checked, does 3 go into 15? Okay, and 3 does go into 15. It goes in there 5 times. Anybody have questions about that? Yeah, the 2.5 isn't going to work, right? Because it's not a whole number. Now, I don't want to lie to you guys. We totally could factor out using a 6 and getting a decimal. There's nothing wrong with decimals. It's just for right now, we're only going to do whole numbers, okay? If you guys go further in math, like with my pre-calc and my calculus students, we factor out and get fractions all the time, and it's perfectly fine. But the name of the game now is whole numbers, so we're only going to focus on whole numbers. Okay, so let's take a look at letters. I think that the letters was a little less exciting. So this is n times n, and this is n. So we have n times n and n. So this has 2, this has 1, so I'm only going to be able to pull out one n. Okay, and so what do we have here? I'm going to pull out a 3n. And I'm going to pull out a 3n, and then 3 times what gives me 6? That's 2. And then n times what gives me n squared? Well, it has to be another n, right? So 3n times 2n, that's 6n squared. And then 3 times what gives me 15? That's 5. And it's negative, right? So I have to go minus 5, and there's already an n there, so I'm going to go like that. Hey, guys, hopefully you made it farther than you did with your first practice problem. We're at the end of class, so I just wanted to do a couple of things. Make sure you guys are doing your homework. I'm trying really hard to make the homework assignments very doable and short, guys. So you're going to have a new, awesome. You're going to have a new homework assignment. It's 4 questions. You guys can do that. It's going to be due next class. So just remember, my office hours are in the morning because I coach. But having them in the morning, I know you guys are like, oh, the morning, that sucks. Guys, it's the best because that means that you guys could come tomorrow morning and work on this, or you can come Thursday morning to work on this. But please don't show up to class not having done this because 1, it's going to impact your grade, and 2, we're really building off of this next class. So really important to get your homework done. If you need help and you can't make my office hours, email me and say, hey, Mr. Kraft, I'm working on this assignment. I'm stuck on this problem, and I can help you out, okay? I can send pictures of things to get you started. So there's lots of ways we can help. All right? So with that,